Hello, very good morning to everyone. Once again, I am here in front of you and I welcome you all on this online platform of St. Xavier School, Bansur. Today, I am here with the solution of RBSE 12th class board model paper. I will provide you best solution for this model paper so that you will get help for your upcoming board exams. My name is Devendra Singh Tamar and today I am going to introduce you with our school result of previous session. In 2024, we gave state merit, 7th state merit and first rank in our district. This girl, Chavi Chaudhary, got 98.67% marks in board. And then after, this girl, Neha Yadav, got 96.40% marks in board exams. Not only one student, a proper series of percentage is there. Then after 96.20, 95.80, these are from 12th standard, and these all are from 10th standard. Now let's move to our model paper. So today, this is the model paper of senior secondary examination 2025 board. Every year Rajasthan board provides us model question paper just to prepare well according to that model paper and blueprint. So in this series, at very first, question number first, this is of MCQs, section A. Question number first है, let R be the relation in the set N and given by R is equals to A comma B such that A is equals to B minus 2 and B is greater than 6. We have to choose the correct answer, that which ordered pair will belong to this relation. So simply in every ordered pair, this first number is the value for A and second is the value of B. And we will substitute value of A and B in our relation. This A is equals to B minus 2. The ordered pair which will satisfy will be our correct option. Now if we will put at the place of A 2 is equals to at the place of B, four minus 2. 2 is equals to 2. Ordered pair is satisfying, but here one more condition we have as B is greater than 6. So in this first pair B is 4, so this will not be our option. In second pair B is greater than 6, so when we will put this pair at the place of A, 3 is equals to 8 minus 2, 3 is equals to 8 minus 2, 6, both are not equal, so this is not our ordered pair. Next, for option C, at the place of A, 6 is equals to 8 minus 2, 6 is equals to 6. This ordered pair is satisfying our relation, and here B is greater than 6. So this is our correct option. Next is cot inverse minus 1 upon root 3. And we have to find out its principal value. We know that cot inverse minus theta or minus x is equals to, we have one formula for this, pi minus cot inverse x. For this question, we will have pi minus cot inverse 1 upon root 3. Cot inverse minus x means pi minus cot inverse x, and pi minus cot inverse 1 upon root 3 means for what value of theta we get 1 upon root 3 in cot. So it is pi by 3, and pi minus pi by 3, LCM will be 3 pi minus pi, then our answer will be 2 pi by 3. So here also option C is correct. Next is A is equals to Aij is a matrix, a square matrix ordered with ordered m cross n. Now this matrix will be a square matrix, and for the condition of being this matrix a square matrix, this m must be equals to n. M is equals to n. In a matrix, if number of rows are equal to number of columns, then that matrix will be a square matrix. Next is a determinant is given to us, this 2, 4, minus 1 and 2, and we have to evaluate it. So how to evaluate? We will cross multiply simply. 2 to ja 4. In between we will have minus, and 4 multiply minus 1, minus 4. Then 4 minus minus plus 4, 8. This option B is correct option. Next is matrix A is given to us, and we have to find A square. What will be A square? So A square, how will we evaluate A square? A square means A dot A. We will multiply matrix A by A, and then we will get A square. And how? 1, 0, 1, 0, 0, 0, and 1, 0, 1. Okay, fine. Again matrix A, 1, 0, 1, 0, 0, 0, and 1, 0, 1. Now multiply these both the matrix. So how to multiply? First row with first column. 1 multiply 1, 1, plus 0 multiply 0, 0, plus 1 multiply this 1, 1. Then for second element, first row and second column. In second column, all elements are 0. Then these elements, by multiplying 0, we will have all elements as 0. Then first row, third column. This 1 multiply to this 1, 1. 0 multiply 0, 0. And then 1 multiply 1, 1. Then second row, all elements are 0. First column, when these elements will multiply to these corresponding elements, 0 multiply 1, 0, 0 multiply 0, again 0, and 0 multiply 1, 0, and 0. Second row, second column, we will have 0, and second row, third column also, in this also, result will be 0. Then after third row, first column, 1 multiply 1, 1, plus 0 multiply 0, 0, plus 1 multiply 1, 1. Third row, second column, all elements are 0, then result will be 0. Third row, third column, in this we will have 1 plus 0 plus 1. 1 plus 1, 2, 0, 2, 0, 0, 0, and again 2, 0, 2. We can take out 2 as common from each element. Here 2 will be common, then 1, 0, 1, 0, 0, 0, and 1, 0, 1. And this is our matrix A. So instead of this matrix, I can write A. So 2A is our correct answer. Which option? Option A. Now next question is the derivative of sine log x with respect to x is, let our function is y is equals to sine log x, and its derivative will be dy by dx is equals to, now sine, and at the place of x we have log x, derivative of sine x cos, and at the place of x log x. Here at the place of x we don't have x, so we have to find derivative of this log x also, and derivative of log x will be 1 upon x. So our answer will be cos x log x upon x. This is our correct answer. Not x, cos log x upon x. C is the correct option. Next is the rate of change of the area of a circle with respect to its radius. Area of circle pi r square. Change in area means with respect to radius means dA upon dr. We have to differentiate it with respect to r, and pi is constant. Derivative of r square 2r. At r is equals to 6, r is given in this question as 6, then pi into 2 into 6, 6 to ja 12 pi. Option B is correct option. Next is a function is given to us, and this function is continuous at x is equals to 5. This function is a continuous function at x is equals to 5, then value of k we have to find. Means if a function is continuous at any particular point, in that condition we will have left hand limit is equals to right hand limit is equals to value of function at that point. Our function is continuous at x is equals to 5 and f5. These all three will be equal. Means instead of left hand limit and right hand limit, we can write limit x tends to 5 of fx is equals to f is equals to 5. Now we will find out left hand limit in this question. And what will be left hand limit? Limit x tends to 5 minus fx, or we can write limit h tends to 0 5 minus h. Means x, value of x is less than 5, and if x is less than 5, what is our function? X is greater than, x is less than and equals to 5. In this condition our function is px minus 8. So in that function our function is 3x minus 8, and here in this function at the place of x we have to put what? 5 minus h. So limit h tends to 0, 3 at the place of x, 5 minus h minus 8. Now when we will put at the place of h 0, then h will be 0, 3 5 ja 15, 15 minus 8 7. Then after right hand limit, what will be? Limit x tends to 5 plus fx, or limit h tends to 0 f 5 plus h. And here in this condition x is greater than 5, and for x is greater than 5 our function is 2k, and in this at the place of x we have to put 5 plus h. So simply limit h tends to 0, we don't have here x 2k, and we don't have h also to put 0 at the place of h, so this 2k. Both left hand and right hand limits are equal. So by putting these both equal, 2k is equals to 7 and k is equals to 7 upon 2 is our right answer. So option D is correct option. Next is we have to integrate this 1 minus sin x upon cos square x. So how to integrate? Separate these 1 upon cos square x minus sin x upon cos square x dx. Integration 1 upon cos square sec square x minus sin x. Here we have cos square x. Sin x upon 1 cos x will be 10x. In denominator we have 1 more cos x and 1 upon cos x will be sec x. Now integration of sec square x 10x minus integration of sec x 10x will be sec x plus c. This is our integration. So option B is our correct answer. Now next is a curve we have y square is equals to 4x means area of the region bounded by the curve y square is equals to 4x, y-axis and line y is equals to 3. So when we will draw graph for this figure for this y square is equals to 4x, its graph will be like this. Y square is equals to 4x. Y-axis, this is our y-axis, and line y is equals to 3. It's a line. This line is y is equals to 3. So this point will be 0, 3. This point will be 0, 0. So how will we integrate it? Integration. Here we have limit for y-axis means 0 to 3. Then x dy. Now what is the value of x from here? X is equals to y square upon 4. We will put this value here 0 to 3 at the place of x, y square upon 4 dy. Now 1 upon 4 outside. Integration of y square y cube upon 3 and its limit 0 to 3. 1 upon 4 by applying limit y cube means 3 cube upon 3. 3 cube 27 upon 3. 3 9 ja 27. 9 upon 4 square unit is our correct answer. Option B. Next is the solution of differential equation y dash is equals to y square upon 1 minus xy. We have to find out solution of this differential equation. Y dash I can write dy by dx is equals to y square upon 1 minus xy. By reciprocal of this dx upon dy is equals to 1 minus xy upon y square. Dx upon dy is equals to by separating these 1 upon y square minus xy upon y square. 1y to 1y cancel. Transpose this x upon y to RHS side and dx upon dy plus x upon y is equals to 1 upon y square. This is a differential equation of the form dx upon dy plus dx is equals to q. Here at the place of p we have 1 upon y, and at the place of q we have 1 upon y square. So at first we will find out integrating factor if, that will be e raised to the power p dx. E raised to the power at the place of p 1 upon y dy. E raised to the power integration of 1 upon y log y, and e to log cancel, we have y. Now for solution of this differential equation, what will be x dot integrating factor is equals to integration q dot integrating factor dy plus c. X dot, what is integrating factor? Y is equals to integration q, value of q 1 upon y square dot integrating factor y dy plus c. 1 by 2 y cancel. Xy is equals to integration of 1 upon y log y plus c. Transpose log y to that side. Xy minus log y is equals to c. So let's check which option is a correct option. Xy minus log y plus c. If here we will have is equals to 0, plus or minus both signs we can take. So this can be correct option. Here we don't have any option of this way. Differential equation, we don't have any equal sign or anything else, so any we can take. Okay, fine. Now next is the value of a minus b cross a plus b. A and b are two vectors and their cross product is given. So how to do this? A vector cross a vector plus b vector minus b vector cross a vector plus b vector, multiply a cross a plus a cross b minus this b vector to this bracket, then b cross a minus b cross b. Value of a cross a is 0, value of b cross b is also 0. Now what is remaining? A cross b minus b cross a. We know that a cross b is equals to minus b cross a. So instead of this, at the place of minus b cross a, we can put a cross b. So a cross b is equals to a cross b plus a cross b, and a cross b plus a cross b means 2 bracket a cross b. So which option? Option C is correct option. Next is value of this we have to find. So how to evaluate? We have one method like I, j cap, and then k cap by following this arrow. Now j cross k, here j and cross k will be I cap, I dot I cap plus j dot I cross k, I cross k. We are going backward, we are not going in the direction of arrow, then I cross k will be j but with negative sign, plus k dot I cross j, simply we are moving in the direction of arrow, I cross j will be k cap. I dot I means magnitude of I, square of magnitude of I, and that will be 1 minus j dot j will be 1 and k dot will be 1. 1 minus 1 cancel. What is remaining? This one. Option C is correct option. Next is two vectors are there. A vector and B vector, and we have to evaluate magnitude of A cross B. We have to evaluate magnitude of A cross B. So how to evaluate? A vector is equals to I cap minus 7j cap plus 7k cap. B vector is equals to 3i cap minus 2j cap plus 2k cap. What will be A cross B? I cap, j cap, k cap. 1 minus 7, 7, coefficient of these. 3 minus 2 and 2, and we will solve this determinant. I cap, leave this column and this row. Minus 7 multiply to minus 14 minus this 7 multiply minus 2 minus 14 minus j cap, leave this column and this row. 1 multiply to 2 minus 7 3 ja 21 plus k cap, leave this column and row. 1 multiply minus 2 minus 7 multiply minus 7 multiply 3 minus 21. So minus 14 plus 14, this will be 0. 2 minus 2 minus 21 minus 19 minus 19 and this minus, then plus 19 j cap. Here minus 2 plus 21, then plus 19 k cap. This is A vector cross B vector. Now magnitude of a vector, how will we find out? Square root of these scalar components. 19 square plus 19 square. 19 take 19 as common, 19 square as common. Here 1 plus 1, square root of 19 will be 19 and square root we have 2. This is the magnitude of cross product of these two vectors. Option C is correct. Next is perpendicular distance. Perpendicular distance of the point from z axis. Perpendicular distance of any point of a point is suppose x, y, z, and its perpendicular distance from x axis. For this, leave x coordinate square root of y square plus z square. Perpendicular of distance of a point from y axis, leave y coordinate and then it will be x square plus z square. Perpendicular distance from z axis will be square, leave z coordinate and square root of x square plus y square unit is our answer. So option B is correct option. Next is PA is given to us, PB is given to us, and PA intersection B is given to us. We have to find the value of PA by B. Simply we know that PA by B is equals to PA intersection B upon PB. Here what is the value of A intersection B? This is 4 upon 13, and PB, this is 9 upon 13. 13 to 13 cancel, 4 upon 9 is correct option. This. Next is two dices are thrown simultaneously, probability to get total of 5. दो डाइस को फेंका अपन ने, आउटकम्स जो होते हैं 1,1, 1,2, इन लास्ट 1,6, एंड 2,1, 2,2, इन लास्ट 2,6, 3,1, 3,2, 3,6, and in last we will have 6,6. So probability to get total of 5 means on the faces of both dice the sum of numbers is 5. Now in how many ways we can get sum as 5? Suppose on first dice 1, on second 4, on first 2, second 3, on first 3, second 2, and on first 4, second 1. By these 4 ways we can get sum as 5 on both the dices. So our favorable outcomes are 4 and total number of outcomes. When we throw 2 dices, then total 36 outcomes we get. And by simplifying it, 4 1 ja 4, 4 9 ja 36, 1/9 is our correct answer. Next is, a family has 2 children, probability that both the children are boys, given that at least one of them is a boy. A family has 2 children. So what will be our sample space? Suppose that first one is boy and second one is also a boy. I am representing boy with B and girl with G. Suppose first one is boy and second one is girl. Suppose first one is girl and second one is boy. Suppose first one is girl and second one is girl. This is our sample space. Probability that both the children are boys means first one is boy and second one is also a boy. Let I am choosing event E. First child is boy. So in event E, outcomes are first one is boy. In first one boy, in this we have first one as boy. In this also we have first one as boy. Only these 2. And probability of E, what will be? Our favorable outcomes are 2 and total number of outcomes are 4. 1/2. Now F, what is event F? At least one of them is a boy. At least one of them is a boy. Means minimum one boy is there among those 2 children. So at least one boy means one boy must be there. If more than one boys are there, then okay, it will be accepted. So here we have 2 boys, here one boy, then this will also include in F. Here also we have one boy, so this will also include in this. This is F. Now what we have to find in this question? P, probability. Probability that both the children are boys means both children are boys. Both children are boys. This we have to find. Given that at least one of them is a boy. At least one of them is a boy means PF. We choose this event as PF. At least one of them is a boy. What we have to find? Both children are boys. Here we no need to do this. And I can choose event E as both are boys means in this we will have B. First one is boy, second one is boy. This is given, and in conditional probability, the given event we will just keep the downside and upside we have to find E, and its formula will be PE intersection F upon PF. What is E intersection F? here this is event E, this is event F. What is common? This. And its probability PE intersection F 1 upon total 4. PF, probability of PF, in F we have 3 outcomes, total 4, then 3 upon 4. Now probability of E intersection F, this is 1 upon 4, and probability of PF, that is 3 upon 4, 4 to 4 cancel, 1 upon 3 is correct option, and this option is C, option C. Next is question number 2, fill in the blanks are there. First one is sine inverse is a function whose domain is, sine inverse is a function whose domain is, so domain, suppose that y is equals to sine inverse x is a function. Domain is what can be put at the place of x are the values of domain, and here at the place of x we can put numbers from -1 to 1, or we can write this by this way: x is greater than and equals to -1 and less than equals to 1. In both the ways we can write domain of sine inverse x. Next is a determinant is given to us, plus this is equals to 0, and we have to determine the value of k. So how to determine? Determinant a minus b minus c minus a b minus c minus a minus b and c plus k abc is equals to 0. We have to evaluate the value of k, evaluate k. So simply we can solve this determinant, or we can take out common also from determinant, and from determinant, from any row or from any column we can take anything as common, which is common. So here from this column we can take a as common. So what will remain? 1 minus 1 minus 1. From this second column we can take out b as common, and what will remain? -1 1 minus 1, and from third column we can take out c as common, then -1 minus 1 1 plus k abc is equals to 0. Now this abc, by evaluating this determinant first along with r1, then 1 by leaving this column and this row, 1 multiply 1 1 minus -1 into -1 plus 1 1. In between we have minus -1 by leaving this column and this row, -1 multiply 1 -1 minus -1 into -1 plus 1 plus 1. Then third element is -1 by leaving this column and this row, -1 into -1 plus 1 minus 1 into -1 minus 1 plus k abc is equals to 0. Here abc 1 minus 1 0, this complete term will be 0, minus minus plus 1, and -1 minus 1 minus 2 multiply plus 1 minus 2. Here 1 plus 1 2, and 2 multiply by -1, then -2 plus k abc is equals to 0. Take abc as common. Here we will have -4 plus k is equals to 0, and by putting this equals to 0, -4 plus k is equals to 0, k will be 4. So value of k is 4. Next is the absolute maximum value of the given function fx in the interval 1 comma 5. So first of all we will find out f dash x for absolute maximum or minimum value. Just find f dash x, that will be derivative of this function x square 2x minus derivative of 4x 4 by f dash x is equals to 0, 2x minus 4 is equals to 0, and 2x is equals to 4, and x is equals to 4 upon 2, and this 2 belongs to 1 comma 5. Now we have 3 points 1, 2 and 5, and at these all 3 points we will check the value of our function. Firstly f1 1 square minus 4 into 1 plus 8, 1 square 1 minus 4 plus 8, 8 plus 1 9 minus 4 5. Then after f2 2 square minus 4 into 2 plus 8, 4 to 8 minus 8 plus 8 cancel, we have 2 here, and f5 at the place of x we will put 5, then 5 square minus 4 into 5 plus 8, 5 square 25 minus 4 5 ja 20 plus 8, 25 minus 25 plus 8 13. So we will have absolute maximum value of this function 13, and at which point we are getting this absolute maximum value? At x is equals to 5. This is our correct answer. Next is integration of this x square 1 upon x square plus 2x plus 2. So I can write this function as 1 upon x square plus 2x plus this 2 I am writing 1 plus 1 dx. 1 upon this x square plus 2x plus 1 is whole square of x plus 1, and 1 I can write 1 square. Now we have one formula of finding integration, and that is integration 1 upon x square plus a square dx is equals to 1 upon a tan inverse x upon a plus c. Here this is our x and this is our a. So put these values in this formula. 1 upon at the place of a 1, tan inverse at the place of x we have x plus 1 upon at the place of a we have 1 plus c, or I can write tan inverse x plus 1 plus c is our required integration. This was the fourth of fill-ups. Now fifth fill in the blanks is the integrating factor of a differential equation x dy by dx plus 2y is equals to x square. So divide this complete equation by x, we will have this x to x cancel, and here also x to x cancel. So equation we have now dy by dx plus 2y by x is equals to x square, and this equation is in the form of dy by dx plus py is equals to q, and what is the multiple of y? P. Here p is 2 upon x, and integrating factor e raised to the power p dx, e raised to the power at the place of p 2 upon x dx. E and integration of 2 upon x, 2 is constant, integration of 1 upon x log mod x. Now this 2, we have one formula, log a raised to the power b is equals to b log a. We just write power ahead of this log, and if we have any number just with log, we can take that number as power. So e raised to the power log x square, e to log cancel, what is remaining? X square. This is our integrating factor. Next is projection of vector. This, suppose this is a vector and this is b vector, and projection of a vector on any other vector, projection of a vector on b vector. How we evaluate a dot b upon magnitude of b? And a dot b, a is 2 I cap minus 3 j cap dot b is 3 I cap plus 2 j cap upon magnitude of b. This is our b vector, then square root of 3 square plus 2 square. 2 3 ja 6 minus 3 2 ja 6 upon square root 3 square 9 plus 4 13. 0 upon root 13, and this will be 0. It's the projection of a vector on b vector. Now we have a very short answer type questions. These questions are also 1 mark each. First one is, this matrix A is given to us, this matrix B is given to us, and we have to find the value of transpose of AB. So firstly we will multiply A by B. A is 1 3 minus 6, B minus 2 4 5. First row, first column. And how to multiply? 1 multiply minus 2, then minus 2, plus 3 multiply 4, 12, and minus 6 5 ja minus 30. 12 minus 2, 10, and 10 minus 30, minus 20. AB is minus 20. And transpose of AB dash, rows will be column and columns will be rows. This will also be same, minus 20. Or a single element we can write in matrix form or like this also. Next is, if A is this determinant, then find adjoint of A. In this case, an adjoint of A we have to find. And how to find adjoint of A? If we have a determinant of 2 by 2, like A11, A12, A21, A22. So how to find adjoint of A? Just change these elements of diagonal. How? A22, A11, and change sign of remaining elements, minus A12 minus A21. Same in this, change these diagonal elements 7, 4, and with these two elements just change their sign. If plus then minus, and if minus then plus. Next is, prove that the logarithmic function is increasing on 0 to infinite. Means we have a function fx is equals to log x, and x belongs to 0 to infinite. We have to prove that this function log x is increasing on this x belongs to 0 to infinite. Now by differentiating this function log x, differentiation of log x 1 upon x. Now here, for all x belongs to 0 to infinite, whenever we will choose any x greater than 0 up to infinite, this 1 upon x will be greater than 0. 1 upon x will be greater than 0, or we can say greater than and equals to 0. Means here f dash x is greater than equals to 0. So fx is increasing on 0 to infinite. This is the solution for this logarithmic function is increasing on 0 to infinite. Next is a function is given to us y is equals to log cos x. We have to find dy by dx, and simply how to find dy by dx? Log, and at the place of x we have cos x. Differentiation of log x 1 upon x, and at the place of x we have cos x. And here we don't have x at the place of x, we have cos x at the place of x. So derivative of cos x will be minus sin x. Minus sin x upon cos x minus sin upon cos tan x is our derivative. Next is differentiate e raised to the power 10x with respect to x. Means y is equals to e raised to the power 10x, and its differentiation y dash is equals to, we have formula for e raised to the power x, and its derivative will be same, e power x, and here at the place of x we have 10x. So we have to differentiate this 10x also, and differentiation of 10x will be sec square x. This is our answer. Next is the total revenue in rupees received from the sale of X unit of a product is given by this Rx is equals to, then at X is equals to 15, we have to find its income. So differentiation of this function R dash x is equals to 6x plus 36, and at x is equals to 15, R dash 15 is equals to 6 multiply 15 plus 36. 15 6 ja 90 plus 36 126 is our correct answer. So this was the question number 6 of very short answer type questions. अभी आगे नेक्स्ट क्वेश्चन की अपन बात करें. Question number 7. We have to evaluate this by multiplying this x square to this bracket. We will have x square multiply by 1, then x square, and x square multiply by this, then x square to x square will be cancelled. 1 will be there dx, and its integration will be x square x power 3 upon 3 integration of 1 x plus c. This is our answer. Next question is find the area lying in the first quadrant and bounded by the circle x square plus y square is equals to 9. So we have a circle. This circle is passing through this point 3, 0. Here at the place of r square we have 9, means 3 square. By comparing, our radius is 3. This is our radius, and center of this circle is origin. Now for this circle, just to find the area in this first quadrant, we have this formula, value of x 0 to 3 y dx. From this equation of circle we will find out value of y, then y square is equals to 9 minus x square. By taking square root, y will be square root 9 minus x square. 0 to 3 square root 9 minus x square, and this dx. Now integration of square root a square minus x square dx is equals to, what will be, x by 2 root a square minus x square plus a square by 2 sine inverse x upon a plus c. So I can write this as 0 to 3 square root 3 square minus x square. At the place of x, by integrating it x by 2, root a square means 3 square 9 minus x square plus a square upon 2 9 upon 2 sine inverse x upon a. At the place of x and at the place of a 3 plus not plus c, and its limit 0 to 3. Upper limit (3 by 2 root 9 minus at the place of x square 3 square 9 plus 9 by 2 sine inverse at the place of x 3 upon 3 minus, when we will apply lower limit, then at the place of x we will put 0, this complete will be 0, and in this here 0 upon 3 and sine inverse 0 will be 0, and multiply by 9 upon 2, this will also be 0. So this 9 minus 9 0, this will be cancelled, so 9 upon 2 multiply 3 to 3 cancel, and in sine inverse, value of sine inverse 1 is pi by 2, so this will be 9 pi by 4, our correct answer, square unit. This is the correct answer. Next is prove that the function y is equals to x square plus 2x plus c is a solution of the differential equation y dash minus 2x minus 2. So simply differentiate this function y dash x square 2x, differentiation of 2x 2, and differentiation of c is constant and differentiation of constant is 0, and by transposing these two left hand side, y dash minus 2x minus 2 is equals to 0. This is we proved this is the required differential equation for which our function is y is equals to x square plus 2x plus c. Next is find the angle between two vectors a vector and b vector with magnitude root 3 and 2 respectively, having a dot b is equals to root 6. So if dot product is given, then angle between both the vectors will be cos theta is equals to a dot b upon magnitude of a into magnitude of b. What is a dot b is given in question, root 6, magnitude of a root 3 and magnitude of b 2. Here I can write this root 6 as root 3 multiply root 2, root 3 to root 2, root 3 to root 3 cancel, and I can write this 2 as root 2 multiply root 2, root 2 to root 2 cancel, upside we have 1 and downside we have root 2, this will be cos theta, and in cos theta 1 upon root 2 is cos pi by 4, and both side by removing cos we have theta as pi by 4. This is our correct answer. Next is find the equation of the line passing through the point with position vector 2i minus j plus 4k cap and is parallel to the vector 2i cap minus 2i cap I cap plus 2j cap minus k cap. So equation of line passing through the position vector, one position vector is given in parallel vector is given, then equation of line vector equation we have to find. Here only equation of line is written, and here vector equation we have to find. So I am telling you vector equation. So vector equation is a vector plus lambda b vector. By this position vector, this is our a vector, and this parallel vector is our b vector. So simply put these vectors to I cap minus j cap plus 4k cap plus lambda. B vector means I cap plus 2j cap minus k cap. This is our required equation of line. Next is find PA intersection B. If PA is given to us, PB is given to us, and PA union B is given to us. We know that PA union B is equals to PA plus PB minus PA intersection B. These all values we have. PA intersection B is 8 upon 15. PA is 2 upon 5 plus PB is 1 upon 3 minus PA intersection B. Transpose PA intersection B to that side. PA intersection B will be of plus sign. 2 upon 5 plus 1 upon 3 we already have here. By transposing this to this side, 8 upon 15. LCM will be 15. 5 3 ja 15. This will multiply by 3. 3 5 ja 15. 15 1 ja 15. 2 3 ja 6 plus 5 minus 8. And 6 5 11 minus 8. 3 upon 15. By simplifying, 1 upon 5 is our correct answer. This was the last 12th part of very short answer type questions. Now let's move towards section B and question number 4. First one is show that the function f r2r given by fx is equals to x cube plus 5 is injective function. We have to prove that this function is injective function, or instead of injective, 1 word also we can use. That given function is 1. We have to prove this. So how to prove? Let x1 comma x2 belongs to domain of R, and we will find out value of function at this point x1. This will be x1 cube plus 5. Value of our function at this point x2. This will be x2 cube plus 5. Now let fx1 is equals to fx2. We will put these both the values of function as equal, and at the end if we are getting x1 is equals to x2, it means our function is injective or 1, otherwise not. So value of fx1 x1 cube plus 5, value of fx2 x2 cube plus 5. 5 to 5 cancel. X1 cube is equals to x2 cube, and by taking cube root of both sides, x1 is equals to x2. So here we are getting x1 is equals to x2. So given function is injective, or we can say 1 function. This was the 4th question. Now let's move to the next question. Write the following function in the simplest form. We have to write this function in the simplest form. So at very first, I will divide these all by cos x, this by cos x, this by cos x, and this sin x by cos x. What will I have? Tan inverse cos x divided by cos x 1 minus sin x divided by cos x tan x upon cos x divided by cos x 1 plus sin x upon cos x tan x. And this tan inverse at the place of 1 I can write tan pi by 4. Value of tan pi by 4 is 1 and pi by 4 minus tan x upon this is 1 plus I can write tan pi by 4 tan x. Value of tan pi by 4 is 1 and 1 multiplied tan x will be same as tan x. Now by observing this is the formula of tan a minus tan b upon 1 plus tan a tan b. So we can write tan inverse tan a minus b. This is verifying formula of tan a minus b. So that is tan inverse tan pi by 4 minus tan inverse to tan cancel pi by 4 minus x is the simplest form of given function. Next is find the values of x and y from matrix equation. We have two matrix equations. By comparing corresponding elements, we will have our values of x and y. First one is 3x plus 7, that is equals to 0. By comparing, so 3x is equals to, by transposing 7 to RHS side, minus 7, and x is equals to minus 7 upon 3. This is the value of x. Second, 5 is equals to 5 minus 2. This element is equals to this element. Corresponding elements are equal. Transpose minus 2 to this side. 5 plus 2 is equals to y, and y will be 7. Here again y plus 1 is equals to 8. So from this also we will get y is equals to 7, and this from this 2 minus 3x is equals to 4. 2 minus 3x is equals to 4. So 3x transpose this side, then 2 minus 4, this will be minus 2 is equals to 3x, x is equals to minus 2 upon 3. Here we are getting two values of x is equals to minus 7 upon 3, minus 2 upon 3, and y is equals to 7. So next question is question number 7. If x is equals to minus 1 is a root of this equation of determinant, then find the sum of other two roots of this equation. So let's expand this directly along with this R1. So firstly x, by leaving this first column and first row, x into x square minus 1 into 2 minus 2 second column and first row. We will eliminate these elements are remaining 1, 1, 3 and x, then 1 into x minus 3 plus 3. By eliminating third column and this first row, we have these 4 elements, and by multiplying these 2 1 ja 2 minus 3x. By simplifying these, x into x square, x cube minus 2x minus 2 into x minus 2x minus 2 multiply minus 3, then plus 6 plus 3 2 ja 6 minus 3 3 ja 9x, x cube minus 2x minus 2x minus 4x minus 9x minus 13x plus 6 plus 6 12 is equals to 0. This is a cubic polynomial and its 1 0 is given to us. We have to find the sum of other two zeros. Now relation between zeros of a cubic polynomial is alpha plus beta plus gamma is equals to minus b upon a. Here b is the coefficient of x square and a is the coefficient of x cube. So here 1 root is given to us as 1 minus 1. plus beta plus gamma. Sum of other two we have to find out is equals to minus b means coefficient of x square. We don't have here term x square, then its coefficient will be 0 upon coefficient of x cube is 1. So minus 1 plus alpha plus beta is equals to 0, and alpha plus beta is equals to, by transposing minus 1 to this side, this will be plus 1. So the sum of other two zeros or sum of other two roots is 1. This is question number 7. Now question number 8 is sine inverse root x, and we have to differentiate it with respect to x. So y is equals to sine inverse cot x, and differentiation of sine inverse x is 1 upon root 1 minus x square, and here at the place of x we have cot x, so cot square x. Now at the place of x we have cot x, so we will differentiate this cot x also, and differentiation of cot x is minus cosec square x. Now, so finally our answer is minus cosec square x upon root 1 minus cot square x. So let's move towards the next question. Minus cos square x. Next is, it is given to us y is equals to sine inverse x plus sine inverse root 1 minus x square, and we have to find dy by dx. Let x is equals to sine theta, then y is equals to sine inverse sine theta plus sine inverse root 1 minus, at the place of x, sine square theta. Sine inverse sine theta, sine inverse to sine cancel, theta is there, plus sine inverse 1 minus sine square theta cos square theta, and square to square root cancel, sine inverse cos theta, and we can write cos theta as sine pi by 2 minus theta. Sine inverse to sine cancel, and we have y is equals to theta plus pi by 2 minus theta, theta minus theta cancel. What is remaining here? Pi by 2. This is y is equals to pi by 2, and its differentiation will be dy by dx is equals to pi by 2 is a constant, and its derivative will be 0. Next is, we have to prove whether this function x cube minus 3x square plus 3x minus 100 is increasing in R. So by finding derivative of this function f dash x is equals to 3x square minus 6x plus 3x plus 3, and derivative of this 100 will be 0. F dash x is equals to, by taking 3 as common, x square minus 2x plus 1, and this is the whole square of x minus 1. We know that this 3 is always greater than 0, and whole square of anything that will always be greater than and equals to 0. This will be greater than and equals to 0. So f dash x is greater than and equals to 0 for all x belongs to R. So this function is increasing in R. Next question is, we have to evaluate this, and we know that e raised to the power x fx plus f dash x, and its integration will be e raised to the power x fx plus c. We must have a function and its derivative here. Now 1 upon x is a function, let it is fx, and derivative of 1 upon x will be minus 1 upon x square. So this is our f dash x, and its integration will be e raised to the power x into 1 upon x, or I can write x in the denominator of e raised to the power x plus c. This is our answer. Next is, we have a line y is equals to 3x plus 2, and we have to find the area of the region bounded by the line y is equals to 3x plus 2, and x axis and the coordinates x is equals to -1 and x is equals to 1. So y is equals to 3x plus 2. If x is equals to 0, then y is equals to 2. This will be our 1 point. And if y is equals to 0, then x is equals to -2 upon 3. This will be our second point. X 0 and y 2, 0, 2. And x -2 by 3, y 0, -2 by 3, and this 0. This is second point. So equation of line will be like this. One more thing, x-axis, this is x-axis, and the ordinates x is equals to -1 and x is equals to +1. X is equals to -1 we will have here. Suppose this is x is equals to -1, and here we have x is equals to +1. So we have to find the region bounded by this. This region we have to find out. And for this region, here we have our limit from -1 to -2 by 3, -1 to -2 by 3 y dx, and its magnitude. This region is just downside to x-axis, so area will be negative. Just to make that area positive, we have to take mode of this area, and then limit -2 to 2 by 3 to 1, and area for area y dx. Now what is y? -1 to -2 by 3 at the place of y, 3x plus 2 dx. Its magnitude, integration -2 by 3 to 1 at the place of y, 3x plus 2, and this dx. Its integration, 3x square upon 2 plus 2x, 3x square upon 2 plus 2x, and limit -1 to -2 by 3, plus again integration will be same, 3x square upon 2 plus 2x, and its limit will be -2 by 3 to 1. Simply by solving this we will get our answer. And let's solve. 3 multiply x square means -2 by 3 square upon 2 plus 2 multiply at the place of x, -2 by 3, minus, now lower limit -1, 3 multiply -1 square upon 2 plus 2 multiply -1, and its magnitude, plus upper limit 3 multiply 1 square 1 upon 2 plus 2 multiply 1 2, minus 3 multiply -2 by 3 square upon 2 plus 2 multiply -2 by 3. Okay, 3 multiply -2 square 4 upon 3 square 9 by 2. 2 multiply -2 -4 by 3, minus 1 square 1 multiply by 3 3 by 2. 2 multiply -1 -2, and -2 multiply by minus plus 2, plus this is 3 by 2 plus 2, and here minus 2 square upon 3, 3 multiply 2 square 4 upon 9 upon 2. This 2 multiply minus 2 minus 4, and multiply by this minus, then plus 4 upon 3, and 3 1 ja 3, 3 1 ja 3, 3 3 ja 9, upside 4, downside 2, 3 ja 6, minus 4 upon 3, minus 3 upon 2, plus 2, plus 3 by 2, plus 2, 3 3 ja 9, 4 upon 6, plus 4 upon 3. Here LCM will be 6, 6 1 ja 6, 4, 3 2 ja 6, 4 2 ja 8, 2 3 ja 6, 3 3 ja 9, and 1 6 ja 6, 6 2 ja 12. Plus in this side LCM 6, 2 3 ja 6, 3 3 ja 9, 6 2 ja 12, minus 4, 3 2 ja 6, 4 2 ja 8. Here 12 plus 4 16, minus 8 minus 9, then minus 1 by 6, plus in this side 12 minus 4 8, 8 plus 8 16, 16 9, 25 upon 6. Magnitude, then result will be positive 1 upon 6, plus 25 upon 6, 25 plus 1, 26 upon 6 by 13 upon 3 square unit. So lengthy question this was, but easy question, only calculation is long, and in this calculation part we must need to take care. There are a lot of chances that our calculation can be wrong, can go wrong. And never forget to write this unit, square unit with area. Let's move to the next question. Now we are in section C. Question number first is evaluate this integration. So I can write this by dx upon, I can take minus h common. So x square plus 6x minus 7. If I will take minus h common, their sign will change, x square, this minus will be plus, this minus will be plus, and 7. We have plus with 7, and this will go minus. We will make perfect square here. And how will we make perfect square? Here we have coefficient of x as 6. So half of coefficient of 6, we will multiply this by 1 upon 2, and its square, 2 1 ja 2, 2 3 ja 6, and 3 square 9. We will add and subtract 9 in this. So dx upon minus x square plus 6x plus 9 minus 9, and this minus 7 which was already present there, dx upon minus, this will be x square plus 6x plus 9, this will be x plus 3 and its whole square, minus 9 minus 7 minus 16, and minus 16 will be square of 4. Again dx upon multiply by minus, then 4 square will be at first, and minus x plus 3 whole square will be after. Here at the place of a we have 4, and at the place of x we have x plus 3, and integration of dx upon a square minus x square is equals to integration 1 upon 2a log mod a plus x, a minus x plus c. This is our formula. So simply put all these values 1 upon 2 multiply at the place of a, 4 log mod a plus x. What is a? 4 plus x At the place of x, x plus 3. Again a 4 plus minus at the place of x, x plus 3 plus c 1 upon 8 log mod upside x plus 7 downside 4 minus x minus 3 plus c 1 upon 8 log magnitude of x plus 7 upon minus x plus 1 plus c. Further we can simplify it just to match out answer of our book. This was question number 14th, and the part which is in or of to this question, evaluate 2x upon x square plus 3x plus 2. By partial fraction we will solve this question as by factorizing this we can write 3x as 2x plus x plus 2. This is x square. By taking x as common, x plus 2 plus 1 x plus 2, and two factors will be x plus 2 and x plus 1. So by partial fraction 2x upon x plus 1 x plus 2, a upon x plus 1 plus b upon x plus 2. 2x is equals to a will multiply by 2x upon x plus 1 x plus 2. Here LCM will be x plus 1 and x plus 2. X plus 1 is cancelled by this x plus 1. A will multiply by x plus 2 plus b, x plus 2 is cancelled, b will multiply by this x plus 1. So now we will compare, we will solve and we will compare just to find out the values of a and b, and then after it's very easy. Okay, so now this denominator part is cancelled. 2x is equals to a multiplied by x ax, a multiplied by 2 into a, b multiplied by x bx plus b multiplied by 1 b. Now firstly we are comparing coefficient of x. Here with x we have 2 is equals to, with x we have a, with x we have b. So a plus b is equals to 2, and here this side we have constant as 0, this side constant is 2a plus b. By solving these by elimination method, minus 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 b minus b cancel, a minus 2a minus a, and here 2 minus 0 2, so a is equals to minus 2. A is minus 2, put a is equals to minus 2 in this, transpose minus 2 to that side, that plus 2, b will be 4. So by integrating this we just need to put here the values of a and b, and simply we will integrate it. At the place of a, minus 2 upon 1 plus upon x plus 1 dx, and plus 4 upon x plus 2 dx, minus 2 log mod x plus 1 plus 4 log mod x plus 2 plus c. This is our answer. We can simplify this further also. How? This power 2, this will be this will go in power, then minus log x plus 1 whole square. This will also go in power, log x plus 2 power 4. This is log a minus log b. So its formula will be log a upon b. At the place of a, x plus 2 power 4, at the place of b, x plus 1 its whole square plus c. This is our final answer. In next question, there are some mistakes in questions, like this is e raised to the power 10 by dx plus 1 minus e power x sec square. At the place of x, y will be there, sec square y dy is equals to 0. So how to, at the place of this x, just put y. So how to solve this? E raised to the power x 10y dx, transpose this part to RHS side, minus 1 minus e raised to the power x sec square y dy, and when we will find out the value of dy by dx, then e raised to the power x 10y upon 1 minus e raised to the power x sec square y dx को dy के नीचे लेके आए, इसको इसके नीचे लेके गए. नाउ बाय सेपरेटिंग द वेरिएबल्स को अपन सेपरेट करें, तो sec square y will go upside and 10y will go downside to this. Here dy in this side minus e raised to the power x dx will go upside upon 1 minus e raised to the power x. By integrating both sides, in this side let 10y is equals to t and sec square y dy is equals to dt. Sec square y dy is equals to dt and 10y t is equals to, in this side 1 minus e raised to the power x is equals to u, and by differentiating it minus e raised to the power x dx is equals to du, then minus e raised to the power x dx is equals to du, and at the place of this u. Now by integrating 1 upon t log mod t is equals to log mod u plus log c. What is the value of t? At the place of t 10y, log mod u at the place of u 1 minus e raised to the power x plus log c. Log 10y is equals to log a plus log b, then log ab 1 minus e raised to the power x into c. By removing log from both sides, then 10y is equals to 1 minus e raised to the power x into c. This is our required solution of given linear equation. Its next part is cos dy by dx is equals to a, and particular solution we have to find out in this question at y is equals to 1 and x is equals to 0. So by this dy by dx will be cos inverse a. By separating dy is equals to cos inverse a dx, by integrating both sides, integration of dy by cos inverse a is constant and dx x plus c. Equation first. Now put in this x is equals to 0 and y is equals to 1 at the place of y 1, at the place of x 0, and this complete will be 0 plus c, and c will be 1. Value of c is 1 here. Put c is equals to 1 in equation first, and y is equals to cos inverse a with this x plus 1. Transpose this 1 to that side, then y minus 1 is equals to x cos inverse a. Take 1 in the denominator of this cos inverse a, and a is equals to cos y minus 1 upon x is the required particular solution of the given equation. Next is equation of, find the Cartesian equation of the line which passing through the point. Our line is passing through this point and is parallel to the line given by. So equation of line x minus x1 plus upon a is equals to y minus y1 upon b is equals to z minus z1 upon c. Now this equation is passing through minus 2, 4, minus 5. This minus 2 is our x1, this 4 is our y1, and this minus 5 is our z1. And our line is parallel to this line. So these are the direction cosines of another line. So if two lines are parallel, then their direction cosines will be same. So A will be 3, B will be 5, and C will be 6. Put all these values x minus at the place of x1 minus 2 upon A 3 is equals to y minus y1 4 upon B 5 is equals to z minus z1 minus 5 upon C 6. Simplify it, x plus 2 upon 3 is equals to y minus 4 upon 5 is equals to z plus 5 upon 6. This is our required equation. Next is we have to show that given points are collinear. Show that the points, these 3 points are collinear or not. This we have to show. How will we show? That point A is 2, 3, 4. Point B is minus 1, minus 2, 1. And point C is 5, 8, 7. We have these 3 points and we have to prove that these 3 points are collinear points. Simply, many ways are there. We have many methods just to prove them congruent. So let's find out direction ratios of AB, line AB. Direction ratios of AB. How will we find out? Suppose this is x1, y1, z1. This is x2, y2, and z2. x2 minus x1, y2 minus y1, and z2 minus z1. x2 minus x1 means minus 1 minus 2, minus 2 minus 3, and 1 minus 4. And will be minus 3, minus 5, and minus 3. Then after direction ratios of BC. Direction ratios of BC. How will we find out? x3, y3, z3. 5 minus minus 1, 8 minus minus 2, and 7 minus 1. 5 plus 1, 6, 8 plus 2, 10, 7 minus 1, 6. And let these are A1, A2, A3, B1, A1, B1, C1. These are A2, B2, C2. And by comparing them, A1 upon A2 minus 3 upon 6 minus 1 upon 2. B1 upon B2. B1 is minus 5, B2 is 10. Again minus 1 upon 2. C1 upon C2 minus 3 upon 6. This is also minus 1 upon 2. All direction ratio of their direction ratios is same. So, and instead of BC, we can find AC also. Direction ratios of AC means A2C means A2 direction ratios of AB will be same as direction ratio of AC. So both the lines are collinear. Next is so let's move to the next question, which is question number 17, and that is a question of probability. Here there are 3 coins. We have 3 coins. One is a two-headed coin, Another is a biased coin that comes up head 75% of the time, and third is an unbiased coin. One of the coin is chosen at random and tossed. It shows head. What is the probability that it was the two-headed coin? Means we have three coins. We have three coins. So this is our first coin, this is our second coin, this is our third coin. In first coin, both the times we are getting head. In second coin, 75% we are getting head and remaining 25% we are getting tail. And third coin, this third coin is an, an unbiased coin. In this 50% is the possibility of occurring head and 50% is possibility of occurring tail. Now, there are three coins. So, let even we will divide these coins. We will consider these coins occurrence of choosing of any coin will be an event. So even event means first coin is to be chosen, has to be chosen, and E2 means second coin has to be chosen, and E3 means third coin has to be chosen. Now we have total three coins, then probability of choosing first coin, there are three coins, then total number of outcomes will be 3, and by probability of choosing first coin, in that case our favorable outcomes are 1. So probability of choosing first coin is 1/3. Probability of choosing second coin is also 1/3, and probability of choosing third coin, this is also 1/3. Now we will consider our event A, and that is head occurs at coin. Means we are choosing a coin and at that coin head occurs. Suppose that now we will find out conditional probability that first coin is chosen. First coin is chosen and head is occurring on that coin. So on the first coin, first coin is a two-headed coin. So whenever we will toss by first coin, both the times we will get head. So probability of getting head on the first coin is 1. Then after E2 means second coin is chosen, and A means we are getting head. Now second coin just giving head 75%. So probability of occurring head on second coin is 75%, means 75/100. By simplifying it, 25 3s are 75 and 25 4s are 100. Probability of choosing third coin and then probability of occurrence head. Third coin is an unbiased coin, and in that on that coin probability of getting head is 1/2, means both are equally likely outcomes. There are 50% probabilities of getting head and 50% for tail. Now we have to find the probability that what is the probability that it was the two-headed coin, means one coin is chosen, and one of the coin is chosen at random and tossed, it shows head, means head occurs on that coin, and which we know already that comes in denominator. Now what is the probability that it was the two-headed coin? Two-headed coin was first coin. So even we have to find out. Now by Bayes' प्रमेय, Bayes' theorem, probability P even PA by even, and downside P even PA by even plus PE2 PA by E2 plus P E3 PA by E3. This is our formula. Simply we will put our all values here. P even, what is P even? 1 upon 3 multiply PA by even, that is 1 upon P even 1 upon 3 multiply PA by even, that is 1 plus PE2 is 1 upon 3 into PA by E2, that is 3 upon 4 plus PE3, that is 1 upon 3 multiply PA by E3, that is 1 upon 2. Now 3 to 3 cancel. Upside we have 1 upon 3. Downside is 1 upon 3 multiply by 1 upon 3 plus here 1 upon 4 plus 1 upon 6. In denominator we will take LCM. LCM will be 12. 3 4 ja 12, 4 3 ja 12 and 6 2 ja 12. Now 1 upon 3, 4 plus 3 7, 7 plus 2 9 upon 12. So these interior terms will multiply and outer terms will multiply, and upside 12, downside 3 multiply 9, 3 4 ja 12, 4 upon 9 is our right answer. So this was question number 17th. Or part of this question number 17 is a box containing 10 black and 8 red. Black balls are 10, red balls are 8. For the first part, find the probability that both balls are red, two balls are drawn at random without replacement. Means we are taking out one ball from that bag and we are not replacing that ball. We are not keeping that ball in that bag. So for the first part, let event even is first ball is red and its probability will be probability of first ball as red. Total red balls 8 and total balls 18. 8 upon 18. E2 second ball is red. Occurrence of first ball as red is not affecting that second ball is red. Probability of getting second ball red and when first ball was red, total red balls were 8. Now one ball has taken out and kept outside from bag. Now total red balls are remaining 7 and total balls are 17. Now we are getting probability of getting both red balls. Both balls are red. Both are independent events. Means occurrence of one is not affecting the other. So P even intersection E2 is equals to P even multiply P E2. P even, that is 8 upon 18. P E2, that is 7 upon 17. 2 4 ja 8, 2 9 ja 18, 4 7 ja 28 and 17 9 ja 153. This is our correct answer for the first part. Now for the second part, first ball is black and second is red. Even is first ball is black. So its probability P even, its probability will be total black balls 10 and total balls 18. E2, second ball is red, probability of E2. Now when first ball was black, then after total black balls are 9 and red are 8, and probability of getting red ball, total red ball 8, total balls 17. And both are independent events, then even intersection E2 will be P E1 dot P E2. So 10 upon 18 multiply by 8 upon 17. 2 5 ja 10, 2 9 ja 18, 8 5 ja 40, 17 9 ja 153. This is our answer. Third part is one of them is black and other is red. Means out of those two balls, one ball is red and one is black. So for this, let two conditions are possible. First one is case first. First is black and second is red, and first is red and second is black. Means P first is black, means let E1 is black and second is red, means intersection E2, plus first is red means E2 intersection E1. So same like these two parts we have done already, we can find out probability of this third part also. One of them is black and another is red. Now let's move towards question number 18th, and that is a question of integration, and very important question. This question might be, you can get this question in your boards also, so understand this question very carefully. Integration 1 to 2 1 upon x minus 1 upon 2x square e raised to the power 2x dx. Now let 2x is equals to t. I am choosing 2x as t. Now by differentiating it, 2 dx is equals to dt, and dx is equals to dt upon 2. From here value of x will be t upon 2. So put these all the values in our equation. 1 upon, at the place of x we will put t upon 2 minus 1 upon 2 into, at the place of x, t upon 2 and its square, this bracket close, e raised to the power 2x, means e at the place of 2x we will put t. Limit also we have to change. When x was 1, here x is equals to 1, then t will be 2 multiply 1 is equals to t, t will be 2. This will be our lower limit. And when x is 2, in that condition 2 multiply 2 is equals to t, 4 is equals to t. This will be our upper limit. So 2 to 4. Now by simplifying it, 2 to 4, this will be, this 2 will go upside in numerator, minus 1 upon 2 into t square upon 4. 2 1 ja 2, 2 2 ja 4, e raised to the power t. Again 2 to 4, this is 2 upon t minus this 2 will go upside 2 upon t square e raised to the power t. And one more thing, at the place of dx we have to put dt upon 2. This 2 will come up ahead like 1 upon 2. So we can take out this 2 as common also. 1 upon 2 multiply this 2 will be common. 2 to 4 in bracket we have 1 upon t minus 1 upon t square e raised to the power dt. This 2 to 2 cancel. Now we know that integration whatever limit is there e raised to the power x fx plus f dash x dx. So its integration will be e raised to the power x fx plus c. Same here. Here this 1 upon x is our fx and its differentiation minus 1 upon x square is our f dash x. So its integration will be e raised to the power t and 1 upon t and its power 2 its limit 2 to 4 e raised to the power t upon t and its limit 2 to 4. Now by applying limit e raised to the power 4 upon 4 minus e raised to the power 2 upon 2. E square upon 2 is common. Here we will have e square upon 2 minus 1. Or once again we can take LCM of this bracket and this will be e square minus 2. This will be our correct answer. This was question number 18th and its OR part. How will we solve? This was the question log 1 plus 10x and its limit 0 to pi by 4. So how to solve this? We will apply this limit here. We have one property integration 0 to a fx dx is equals to integration 0 to a f a minus x dx, and this property we will apply here. Then integration, this is I is equals to integration 0 to a, and at the place of a we have pi by 4 log 1 plus at the place of x we will write pi by 4 minus x. I is equals to 0 to pi by 4 log 1 plus 10 a minus b. We will apply this formula here, 10 a minus b. Then 10 a means 10 pi by 4 minus 10 b means 10x upon 1 plus 10 a means 10 pi by 4 and 10 b means 10x. Value of 10 pi by 4 is 1. Here value of 10 pi by 4 is 1. So what we have, I is equals to 0 to pi by 4 log 1 plus here 1 minus 10x, downside 1 plus 10x. Now we will take LCM and I is equals to 0 to pi by 4 log LCM is 1 plus 10x, then 1 plus 10x plus 1 minus 10x plus 10x to minus 10x cancel. So what we have now, integration 0 to pi by 4 log upside 2 and downside 1 plus 10x. Here by applying log a upon log b formula, I is equals to 0 to pi by 4 log 2 minus log 1 plus 10x and dx. This log 1 plus 10x is our I, our question. So at the place of log 1 plus 10x, I can put I, and by transposing this I to that side, it will give us I plus I, and now 0 to pi by 2. Log 2 we can take outside, and here we will have only dx. I plus I, 2I is equals to log 2. Integration of dx will be x, and its limit 0 to pi by 4. 2I is equals to log 2, and by applying limit pi by 4 minus 0, I is equals to, here pi by 4, this 2 will go in the denominator, then pi by 8, and we have this log 2. This is the solution of this integration. This is a very important as per your upcoming board exams also. So understand this question carefully. Next is question number 19th. Question number 19th. In question number 19th, we have to find the angle between these lines. We have to find the angle between these both lines. Now, these lines are in the form of r vector is equals to a1 vector plus lambda b1 vector, and r vector is equals to a2 vector plus lambda b2 vector, mu b2 vector. So angle between two lines is same, will be same to the angle between their both parallel vectors. So we have to find the angle between these both lines, and that angle will be same as the angle that will be between these both vectors b1 and b2. Here this is our b1 vector and this is our b2 vector. So angle between both lines will be cos theta is equals to I cap plus 2j cap minus 2k cap. Okay, I am writing firstly formula. Cos theta is equals to b1 dot b2 upon magnitude of b1 into magnitude of b2. So this is first vector b1 vector, and b2 vector 2i cap plus 4j cap minus 4k cap upon square root of 1 square plus 2 square plus minus 2 square. Here 2 square plus 4 square plus minus 4 square. 1 multiply 2, 2, 2 multiply 4, 8, and minus 2 multiply minus 4 plus 8 upon square root 2 square 4, 4 8 1 9, square root 4 square 16, 4 square 16, 16 32, 32 plus 4 36, 8 8 16 to 18 upon square root of 9 3, and this 6, 18 to 18 cancel. Now cos theta is equals to 1, cos theta is equals to cos 0 degree. In cos theta at 0 degree we have value h1, so theta will be 0 degree is our correct answer. So this was the question number 19th. Now video is getting too long. I am also tired, so I am not telling you this question of or in next video or somewhere else, or with this chapter I will tell this question. Now let's move towards next question, and that next question is last question, and I am telling this only one part of this last question. Very simple. This is a question of graph. So we have to maximize z is equals to 3x plus 2y. under the following constants. First one is x plus 2y is less than equals to 10. Second is 3x plus y is less than equals to 15, and x and y both are greater than equals to 0. So by changing inequalities into equation x plus 2y is equals to 10, we will make table for this equation x, y. When y is equals to 0, then x will be 10, and when x will be 0, then y will be 5. This is table for first equation. Second equation is 3x plus y is equals to 15. Here x, y. When y is equals to 0, x will be 3 5 is 15, and when x is equals to 0, y will be 15. Now this is our graph. Very simple. This is, here we have 1 2 3 4, on this side -1 -2 -3, here 1 2 3 4, 1 2 3, these numbers will be small. I am taking a scale of 5 5 10 15 and 20. This side also 5 10 15 and 20. This side -5 -10 -15, there is no need. -5 -10 -15. Okay, fine. This first point is, on x-axis we have 10 and on y-axis 0. This will be our point 10, 0. On x-axis we have 0 and on y-axis we have 5. This is 0, 5, our second point. So I am changing color of this, my pen. By joining these both points, this will be our first line, and by putting this origin into our line, at the place of x we will put 0, and at the place of y 0. 0 plus 0, 0 is less than to 10, so it's correct, and our solution field will be to the downward to this line inside of origin. Next is the second point. For second equation we have these points. First one is, on x-axis we have 5, on y 0. This will be our point 5, 0, and 0, 15. This will be our second point 0, 15. So by joining these both points, this is our second line, and our solution field will be by putting 0 at the place of x 0 and y 0. 0 plus 0 is less than to 15. This is true. So for this line also our solution field will be in the side of origin. Now which area we have to determine, means this will be our feasible region. And its corner points are these 4 points. Corner points. First one is this 0, 0. Second one is this 5, 0. Third point is this 0, 5. And this fourth point, we don't have this point, so we will find out this point. And this point is at the intersection of these both the lines. Intersection of these both lines. So we will solve these both lines by elimination method. Here with x we have 3, and here we don't have anything, so multiply this equation by 3. 3x plus 3 2 is 6y, 10 3 is 30, and here 3x plus y is equals to 15. Minus 3x to 3x cancel, 6y minus y 5y, 30 minus 15 15, and y will be 3. Put y is equals to 3 in any of these equation. At the place of y, when 3 we will put 2 3 is 6, and this 6 will come up to this side. 10 minus 6, x will be 4. So this point is 3, 4. This point is also our corner point 3, 4. And here our z objective function 3x plus 2y. Find out the value of this objective function at these all corner points. In first, when we will put 0 0 at the place of x and y, and value of z will be 0. At the place of x we will put 5, and at the place of y 0 for this point, then 3 5 is 15 plus 0, 15. For this point 0, 5 at the place of x 0 and at the place of y 5, and 5 to ja 10. And for this point at the place of x 3 and at the place of y 4, 3 3 ja 9 and 4 to ja 8, and 9 and 8 17. So maximum value we are getting 17 at this point 3, 4. We are getting this 17 as our maximum value of our objective function at point 3, 4. So this is our maximum value of z. So this was the last question of our this model paper 12th board. I hope you all understood well, and very soon I will start making video lectures of our all exercises, all chapters. So till that, keep studying and best of luck. Thank you.